All right, hey, what's up, guys? I'm gonna film this video because we really haven't done too many practice proofs in class yet. So I have here this writing a geometry proof. Your first proof you have to write for homework tonight is problem number 11, and it's just a fill in the blank proof. That's how we can start the year. So just quick reminders on proofs. What we want to do is we want to think when writing a geometry proof, what equations can I create by looking at the diagram? Well, we have angles there. Angles lead us to equations. We'll get to that in a second. And then what property can justify? Maybe an equation I can set up based on the fact that I have angles there in the diagram. Okay. Another thing to keep in mind is how do the equation change? What property justifies the change is valid? Okay. So there are two places that you can really get information to start a proof. One is in the given statements, right? Remember, given just stands for if. If this is true, I want to prove that that has to be true. Okay. So here I got my given premises and I have my given diagram. So I can choose either to really start the proof, given diagram, and let's look to see what they suggest by starting the proof. Okay, so what do we notice here? Is this, do we get this from the diagram or do we get this from the given premises? This is from the given premises. This is just the same exact thing that we see written next to the given up top. So I can write given next to it. Okay, there's my first step. Okay, second step, we want to either decide, is this an equation that I got from looking at the diagram, or is it something that's sort of from statement one built on, right? How did the equation change and what property justifies that change is valid? Well, if I look at this here, measure of angle 1 equals measure of angle 3. I also knew measure of angle 2 equals measure of angle 4. And I have those four angles listed here. So you might be thinking, well, what does this statement 1 have to do with statement 2? And the reality is this, and because I have measure of angle 1 equaling measure of angle 3, I can add equal values to this existing equation here. So if I add measure of angle 2 to the left side of measure of angle 1 here, I get this, measure of angle 1 plus measure of angle 2. Okay, here, check it out. Measure of angle 1 plus measure of angle 2. Well, I'm adding measure of angle 2 to the left side here. That's going to work as long as I add an equal values to the right side of the equation. Okay, adding the same thing to one side of an equation as do to the other will keep the equation balanced. Okay, so if I notice that I have two equations in step 1 and I add the left sides together and add the right sides together, what's going to justify us setting up this equation, okay, is the addition property of equality. So remember, measure of an angle indicates that it's a number. It's not a shape. It's the measurement. Somewhere between 0 and 180 is the measure of any of our angles. Okay, next up here, I got here a couple equations. Well, if I ask myself, how did my equation change from step 2 to step 3? Well, all of a sudden, I'm talking about angle ABC. I'm talking about angle DAF. I wasn't talking about that in step 2. So right, I really can't rewrite this as this down here. I need kind of another reason for it. So that's when I go to my given diagram. Okay, what's going to justify this? Measure of angle 1 plus measure of angle 2 equals measure of angle ABC. What do I see? Measure of angle 1, right? This angle 1 and angle 2, those are the two smaller angles that make up this whole angle here. Part plus part equals whole. So we have here step 2, that's the angle addition postulate. Okay, we get angle addition postulate, not POE, postulate. POE appears in the word postulate. That's not what we want there. Okay, so that means I'm just setting up part plus part equals whole. Part plus part equals whole equals measure of angle DEF. If I'm talking about measure of angle 3 and measure of angle 4. Okay, that gets us to the last step, the thing we want to prove. I want to prove that this whole angle here and this whole angle here are congruent. That's sort of what I set off at the start of that is if this is true, if I have this diagram and I know that those angles are all congruent there as indicated here, then I want to prove that the holes need to be congruent. Part plus part plus part, right? The holes, they got to be the same. And how do I do that? Well, that is the substitution, POE. Substitution, POE. And how does that work? Well, here I made the statements measure of angle 1 plus measure of angle 2. Well, that equaled measure of angle 3 plus measure of angle 4. And I know that, going low on time here, that measure of angle ABC, well, that equals measure of angle 1 plus measure of angle 2 right here. So I can substitute that in. Okay, substitution property of quantity, step 3 into step 2, right? If I'm annotating down exactly what's happening. Okay, measure of angle 3 plus measure of angle 4, well, that equaled measure of angle DEF from step 3. I got there using the angle addition postulate. So I can substitute that in and finish the proof. Okay, so how is the equation changing? Well, in step 1, I was adding the two sides together. That's how I can get the equation changed. Justify it, additional property of equality. Okay. How can I use the diagram to help me? Well, a diagram helps me at adjacent angles.